A 100,000-ton steel fortress sits motionless inside a giant concrete dry dock, surrounded by towering walls and years of construction. It does not look like a ship yet. It looks like a city trapped on land. Then, slowly, everything changes. More than 100 million gallons of water begin pouring into the dock, and one of America's most powerful warships starts to rise for the very first time. This is not a launch in the way most people imagine. There is no dramatic splash, no sudden slide into the sea. Instead, this is a controlled transformation, one of the most important moments in modern naval shipbuilding. The future USS John F. Kennedy, a brand new Ford-class aircraft carrier, is about to stop being a structure under construction and begin its life as a real vessel. Before a carrier can cross oceans, launch fighter jets, and anchor American naval power around the world, it must first do one simple but historic thing. It must float. For the future USS John F. Kennedy, that milestone came at Newport News Shipbuilding in Virginia, the only shipyard in the United States capable of building nuclear-powered aircraft carriers. After years of construction, thousands of workers, and billions of dollars in steel, systems, and labor, the ship finally reached the stage where it could enter the water for the first time. But floating a carrier of this size is not a simple procedure. It is a carefully controlled engineering event. Inside Dry Dock 12, the carrier rested for years on massive keel blocks, while workers built the hull, internal compartments, piping, electrical systems, and the foundations of the advanced technology that will one day support full carrier operations. By the time the ship is ready for first float, it is already far more than an empty shell. It is a steel city, built section by section into one of the most complex warships ever constructed. That is what makes this moment so important. The flooding of the dry dock is not just another construction step. It is the point where the carrier stops being only a project on land and starts becoming a real ship. Newport News Shipbuilding has been at the center of American carrier construction for generations. Deep inside the yard, graving docks serve as the birthplace of the largest warships in the U.S. fleet. Dry Dock 12 is enormous, even by shipbuilding standards, stretching well over 2,000 feet in length and providing enough space to hold a vessel longer than 3 football fields. It is inside this giant concrete basin that the John F. Kennedy took shape over several years. While the carrier sat on keel blocks, thousands of shipbuilders worked through an extraordinary process of assembly and integration. Steelworkers shaped the hull. Electricians installed miles of wiring. Pipe fitters laid out critical support systems. Engineers oversaw the alignment of complex machinery and structural components. Specialists added radar, launch systems, and the framework for life aboard the ship. Every section had to fit into a much larger design, and every detail had to meet exact standards. By the time the ship reached the first float stage, it was already packed with complexity. Passageways, machinery spaces, support compartments, aviation areas, and ship-wide systems were all taking form inside the hull. That is why this event carries so much meaning inside the shipyard. A first float is not the beginning of construction. It is the reward for years of work, the first moment when a massive structure proves that it is ready to behave like a vessel. Then comes the controlled flood. This is one of the most delicate phases in the entire process. Water is introduced into the dry dock slowly and in a carefully planned sequence. Engineers do not simply open the dock and let the basin fill as quickly as possible. Every stage is monitored. Water levels are measured. Structural conditions are checked. Support teams watch how the ship responds as the pressure around it changes. At first, the water rises only enough to reach the lower support level. This stage allows crews to confirm that everything is working correctly before the dock continues filling. As the level climbs higher, buoyancy begins to take effect. For years, the carrier has rested completely on the supports beneath it. Now, for the first time, the laws of flotation begin to share that burden. This transition is gradual, and that is exactly the point. A ship this large cannot be rushed through a moment like this. The movement has to remain controlled. The vessel must shift from fixed support to floating support without sudden instability. What looks calm from the outside is actually a tightly managed engineering milestone. Eventually, the dock reaches full capacity. More than 100 million gallons of water surround the hull. and the John F. Kennedy experiences true flotation for the first time. It is still inside the dry dock, but now it floats under its own displacement rather than sitting fully on its blocks. That moment changes everything. The carrier is no longer only a construction structure. It is now a ship in the most physical sense of the word. For the shipbuilders, engineers, and program teams who spent years bringing the vessel to this stage, this is one of the most meaningful moments in the entire program. It is the first time they can see the carrier as it was always meant to exist. Not dry, silent, and locked inside concrete walls, but afloat in water, ready for the next phase of its life. But first float does not mean finished. Once the carrier is afloat, another phase begins. Tugboats, control systems, and experienced shipyard personnel work together to carefully guide the vessel within the dock and prepare it for movement toward the next stage. At this point, the ship is still far from operational. More outfitting still has to be completed. More systems still need to be installed, tested, and refined. The crew has not yet turned the ship into a war-fighting platform. What this milestone means is that the ship has crossed from construction into transition. Soon after comes christening, another symbolic and historic moment. But even after christening, the path to service remains long. A carrier of this size must go through extensive fitting out work, pier-side testing, machinery trials, system integration, and eventually training at sea. Nothing about the process is rushed, because nothing about a supercarrier is simple. That is especially true for the Ford class. The John F. Kennedy is not just another aircraft carrier. It belongs to a new generation of American supercarriers designed around major changes in technology and efficiency. One of the most important of these is the Electromagnetic Aircraft Launch System, better known as EMALS. Unlike older steam catapults, EMALS uses electromagnetic force to launch aircraft from the flight deck. This provides smoother acceleration, more precise energy control, and less stress on both pilots and aircraft. That change matters because the carrier is not simply built to float. It is built to operate as the center of naval aviation at sea. The Ford class was designed to improve sortie generation, streamline certain shipboard processes, and provide room for future growth. These carriers are expected to serve for decades, and they were built with the idea that new technologies can be added over time. That gives the first float even greater significance. This is not just the launch of a large ship. It is the first physical transition of a platform designed to shape American naval operations well into the future. And the importance of that goes beyond the shipyard. An American aircraft carrier does not sail alone. It eventually becomes the center of a much larger combat formation, supported by escorts, submarines, logistics vessels, aircraft, and thousands of sailors. It carries the ability to project power far from shore, support allies, sustain flight operations, and respond quickly to major events around the world. But none of that begins on the open ocean. It begins here, inside a dry dock, at the exact moment the ship first proves it can float. That is why this milestone matters so much. It is the first visible sign that years of design, labor, engineering, and investment have turned into something real. The carrier is no longer just steel on supports. It is no longer only a project on paper and inside construction halls. It is now a vessel, beginning the transition toward service. For the future USS John F. Kennedy, first float marked the end of one chapter and the beginning of another. More work still remained. More systems still had to be tested. More milestones still had to be reached before the ship could join the fleet. But from that day forward, the carrier had crossed an important line. It had left the fixed world of land construction and entered the world it was built for. So when people later see an aircraft carrier at sea, launching jets from its deck and sailing across open water with escorts around it, they are seeing the final result of a much longer story. Long before the flight deck becomes active, long before aircraft launch into the sky, and long before the ship becomes a symbol of naval power, it begins here, inside a giant dry dock.